Momentum is the measure of an object's unstoppableness. No, unstoppableness is not a real word. It is how hard it is to stop or change the state of motion of something. With this toy truck crashing into this motionless toy truck, the momentum of the moving toy truck causes the other truck to keep going, even though it was at a standstill. The definition of momentum is mass times velocity. Greater mass gives an object more momentum. Greater velocity also gives an object more momentum. The unstoppableness of the truck has increased. To symbolize momentum, we use the letter P. Because momentum is mass times velocity, then the units for P are kilograms times meters per second. Note that it is also a vector, as velocity is a vector. This means momentum is also defined by its direction. Impulse is the change in momentum for an object or a system. It is a vector, which means that a change in momentum can be both a change in unstoppableness and a change in direction. There are two ways to change an object's momentum. First is to change the velocity. The first toy truck slows down, which means an impulse has been delivered to it because its unstoppableness has been changed. If the velocity is an ingredient in momentum and velocity has changed, then that means momentum has changed. Velocity has been changed by applying an outside unbalanced force, in this case, the motionless truck. The amount of change in velocity is determined by the size of the force, and by the amount of time the force was applied. The second way to change an object's momentum is to change the mass of the object. To symbolize impulse, we use the letter J. J equals change in momentum, or delta P. Thus, J equals P final minus P initial, or mass times change in velocity. As we have said before, the amount of change in velocity is determined by the size of force times the amount of time the force was applied. In other words, J can also be net force times amount of time, which makes sense because force is mass times acceleration. Acceleration is change in velocity over change in time. Force, in this deconstructed manner, times change in time equals mass times change in velocity. Now, on to the actual law of conservation of momentum. It states that momentum cannot be created or destroyed. It can only be transferred from object to object. Therefore, if we are discussing change in momentum, we have to define whether or not we are talking about an open system or a closed system in the universe. Closed systems means no momentum is added or removed from the system, and the total momentum is constant. We have affected the combination of variables in the system here, but the total amount at the end is the same as it was in the beginning. In an open system, momentum is added or removed, so total momentum of the system may change. In this case, we have added variables, so the total amount is different from the final amount. Within the universe, it is important to note there is still the same amount of milk and flour. Therefore, momentum was neither created nor destroyed. Remember, if the sum of the external forces on a system is zero, then the system is closed for momentum. If it is not zero, then it is open. But this is just in one dimension. Momentum can also occur in the x and y direction. It entails the same process, but like you would break up forces based on their directions, you would break up the velocity into x and y direction. Now let us determine our cookbook for momentum. Draw a sketch. Set coordinate axis. Break up velocity if necessary. Determine if it is an open or closed system. Fill in two momentum equation and split into two equations if necessary. Fill in unknowns. Solve.